In the last video we created our lap stack and we ended up by shutting down the host, which would have returned us back to the VirtualBox Manager, which we can see there in front of us. In order to create our development environment, what we now need to do is clone the server that we just created, which will then add on the graphical user interface and various other things. So in order to do that, select the host, click on clone. Okay, and this time we can rename it. Okay, so we'll call it Centos Dev Env for our development environment. An important factor is to reinitialize the MAC addresses, otherwise we could end up with a conflict on our network with hosts having the same MAC address. So click next. We want to make a full clone, which is standalone and not linked to the other host. Okay, there we go. Right, now we've got a couple of things to do. Back in our server host, we need to add a second adapter, which will enable it, and we'll attach it to the internal network. And we'll call that internal network DevNet. Okay, and make a note of the MAC address for that particular host. And then again, do the same in our development environment machine. Create a second adapter, enable the host, attach it to internal, and it's going to be DevNet. And again, there's going to be the second machine there. So, okay, those. Power back on the server. Go back into it. Log in as root. Okay, and if you look at our IP address, we can now see that we've got a second host, a second interface card, sorry, which is down here, and it's registered against ENP0S8, which is the bridging interface inside the operating system. So we need to configure that now with a static IP address. So in order to do that, run nm2e, okay, which is the network management text user interface as opposed to a graphical user interface. And we want to edit a connection. And it's wired connection 1 that we're going to edit. So click on down to that. And then we want to go down to automatic and change it to manual. And then show the information. Then we'll add our IP address. So we'll go with 192.168.0.80/24. Okay, and then we can also ignore any IPv6 configuration on this interface as well. And then click OK. That's that done. Go back and then activate the connection. Select wired connection 1 and activate it. Okay, and as we can see, both of those are activated now because of the asterisk is next to them. Let's go back, quit out of that, and then we need to restart the network server. So system control, restart network service. Oh, typo again. Okay, that's that done. If we look at the IP addresses, we'll see now that that one is configured with our static IP address there. The reason why we've got the two interface cards in is that that's a private internal network now, which is completely and utterly invisible to the outside world. So by connecting this second interface to our host here, we can both access the internet and our private internal network inside VirtualBox. If we do the same on the development machine, then our development machine can access directly our server machine without having to go across onto the internet. We've also left the first internet card in there, network card in there, so that we can access the internet through the bridged network in case we need to download software or do any kind of other updates. But our development traffic for our client's web app, that will be just held within our VirtualBox internal network. Okay, so we'll minimize that one out of the way, but we can leave it up and running. And then what we're going to do is we're going to do the same process now in the machine that's going to become our development environment. So this is the clone of the server that we've redone. And if you recall, in a couple of steps ago, we added the second interface card in there. So we can log in as root. Log in as super user. Make a note of where it is. So again, our second interface card is on ENP0S8. So we can run NetManager 2E. Edit our connection, again, wired connection 1. Change the automatic to manual. Show the details. We're going to add an address. And this time it's 192.168.0. Whatever you like really, but 101 will do. Again, don't forget the /24 for the net mask. Ignore IPv4, IPv6, sorry, and then OK that. And if we go back, we can activate the one we want, and there we go. And then quit out of that and restart the network again. Okay, that's done. So if we have a look at our IP addresses now, we can see that that one's up with a 192.168.0.101 address just there. Right, so let's have a go and see if we can ping 192.168.0.80 as our web server. And there we go, we're pinging our web server. So we've got an internal network connection to our web server. And should be able to connect to the HTTP website. Yeah, and we can see there we're on the CPU 6013 server.dev. Okay, so we've now got our internal network connected to our web server. Right, okay. So we've got that bit done. Now let's install our GUI version of the system. But before we do, let's change our actual system host name here. 2E again. And then we'll set system host name. So dev env.dev. Okay, and then we've changed that. So if we quit out of there again, okay, and this time if we exit the system and log out, Okay, and then log back in again. You can already see that the host name has changed to dev-end. In order to make life a little bit easier for us, instead of remembering IP addresses, we can add a static DNS entry into our etc host file, which is mono -w etc hosts. Okay, and on the top line here, put the IP address 192.168.0.80, and then the actual shortcut and various different names we want to use. So we can access it by CPU 6013 as a shortcut, and we can also access it by CPU 6013 .server.dev. Okay, Control X, save those. Again, restart the network. I'm just using the up arrow key to get to a previous command. And then we can try it with elinks http://CPU 6013. And there we go. So that's done the same thing. It's taken us through to our server machine. So that's our internal network set up now. So I'll come out of that. Right. What we need to do now is install our graphical user interface. And in this case, we're going to use the Gnome desktop, which is fairly easy to use, but it's got a lot of functionality. So we'll use yum again, group install, making sure we're doing this on our development environment host. And then it's Gnome desktop as one, and then we also want the graphical administration tools. This will allow us to have some graphical interfaces if we choose to use them for developing and managing our server systems. Right, so hit enter. This will bring in quite a few packages, as you can see. So 651 meg of data and about 681 or about 800 odd packages. So set that rolling and maybe go get a cup of tea. Okay, so that's the software installed. Now before we can access the GUI, we need to change the default target, which will kick in the various different run levels within the system. So at the moment we're at a command line run level, and we want to move it to the GUI run level. So we do this by creating a link to the appropriate target file. So ln -sf, and it's in lib systemd. Oh, forgot the slash. System, and then run level 5.target, and then put a space in there, and then we're going to link that to etc systemd system default target. Okay, now once we've done that, we can now reboot the machine and move into graphical mode. Okay, so just select the top kernel again. Okay, and this has brought us into the graphical mode. We just need to accept an open source license. Our networks are all connected and set up, and it's held on to the historical host name, so we need to change that back. So dev env.dev, apply that, close that bit down, and then we can just hit the finish configuration. And there we go. Here's our graphical environment. So now we can log in with our normal users. Password, whatever it was you set when you initially built the server machine up. And we added the user install. Give it a second to do its configuration thing. Okay, and there we go. So just click through the Gnome startup things. Turn the location services off, we don't really need them, and we can skip adding any online accounts and close the hell. Okay, let's just change the screen resolution a bit. So we've got a little bit more desktop area to work with. Into displays, select from the drop down, and thinking which is pretty reasonable. (16:9) should do the trick. Okay, and that's given us plenty to work with. Okay, so now we're in the graphical environment and we can pretty much install whatever tools we wish to choose. One thing that is worth doing is at the top here is going down to click onto the shared clipboard and then select the bidirectional. Now that'll allow you to copy and paste between your host operating system and your guest operating system. So here's the application menu. So let's open a browser. Now remember, as I said, because we put both interface cards in, we can connect out to the network, to the web, and we can also connect out to our development server. So http://CPU6013, and there we go. So that's our development server. We can also, let's just copy that, we can also access our PHP pgadmin interface. There we go, and now we can see the servers that we accessed, and there it is. And then we can log into that using our usernames that we created before, Bren, and what was my password? TWP underscore DB underscore names. And you can select remember on that one if you want. And there we go. And there's the databases we created. And that is on our server. That's not on our local machine. Yeah, we also have, just change that bit to localhost. Our local development one as well. Okay, the idea being is that you develop and you build it and write it on the development environment, and then you push it over onto the server, which would act as a staging server for you to undertake any tests in the actual runtime environment, which mimics the live server. Okay, let's add a couple of development tools. I happen to like Atom as a text editor stroke IDE. So let's download the RPM because we're using Red Hat. Okay, that'll take a couple of minutes to download. There we go, save that file. Okay, and then to install that, we need to go to our applications and we need to go to the terminal. Okay, so this is just the same as the command line. And then we'll need to go to root. So we go to SU minus, which will elevate our privileges to our super user account. So log in with that, and then we do yum install, and then just go to the directory in your home ren, which will be your username, whatever you chose, downloads, and then the Atom RPM will be in there. So just hit that. It'll bring in whatever dependencies it needs to bring in from the web. Click yes to install that lot. And then it just takes a few minutes just to drop it all in. Okay. If we open up another tab, yeah, we've got two tabs open now, one as our root environment and one as our normal user. So as our normal user, we can now install some packages into Atom, which will turn it into a PHP IDE. Atom has a package manager similar to Yum. It's called APM for the Atom Package Manager. Install. And then we want the Atom IDE UI, which is the Atom IDE user interface. We want the IDE PHP. And we also want to install some language Postgres support tools. So we'll run those. And these will install into our local area as part of our home file. So Atom can be used by many developers on one machine, and each one can have their own specific configurations. So that is quite useful. Okay, so now those have been installed, we can install another useful bit of software, which is pgadmin 3. So back here as root, we go into yum install pgadmin, and let's just see what it brings up. Okay, and there we are, pgadmin 395 x86-64. So I'll chuck that in. I'm just going to bring in some dependencies as well. So, a couple of ways to install Google Chrome. Good website to follow is this one, which gives you the commands that you need to paste in and make it work. Okay, so just do that, and then I think that's pretty much it. There we go, Google Chrome's in. Do the GPG key thing. And then if we go up to our applications, go to the internet, we'll see Google Chrome there. And likewise, if you go into programming, you'll see Atom there. One last thing to do if you want to make life a little easier for you with your development, is link the var.ww HTML directory to one in your home directory. So we'll just add login as root, and then we'll chmod password. So I'll just make sure that we've got the right permissions on the HTML directory. So chmod -r g plus w, which is group add right var w HTML. Okay, and then as our normal user, I need to link using ln -s for a soft link to var ww HTML and then home brain, and I'm going to call it web root. Okay, and if I list the contents of my home directory, we can see that the link is down the bottom there. So I should be able to cd into web root. And I can list the context as index.php. And I can add another file to that. So nano -w index2.php, and I'll put the same thing in there. Save it. And then if I go to the browser, I can go to localhost /index2.php, and there we go. So we've now got a simple way of linking a directory into our root web server file system. There we go. So from here, to get everything running for the will writing partnership setup, you will need to follow Garrett's instructions to install a copy locally on the development environment, and then you'll also need to install a copy on the server environment, which you can do using SSH at the terminal to copy over using SCP, or you can add another location there. So we can enter 6013 SSH. Yep, so log in anyway, and we're going to log in as root, and password, and there we go. So we've actually logged into the root of our machine now. And if we go into var www.html, we can see the index.php file that we created in the lap stack video, and there's the connection to the server there.